Yes. Mm. This sheet? Fractions? Okay, hold on. Can we look at this first? Okay. The timer is not really working very well, but never mind. We have 1 minute on this. All right, so we are doing a quick recap on simplifying mixed fractions. Okay. How? Was it okay? What is 1 3/9 in the simplest form? 1 1/3. Okay, very good. How about 2 8/10? 2. Very good. Let's really practice saying the fraction accurately. 2 4/5. Okay, so in our first one, A, 1 3/9, what was the common factor that you divide by? 3. So you grouped into thirds, and then you got 1/3 of the, after simplifying the fraction, keep the whole as it is. Okay, and then you have 2/8. Is that okay? So if I take my pen here, I highlight the color, say pink. So over here I have so I'm grouping it into thirds instead. And then this one, I group it into, what is the common factor that I divide by this? 2. So a bit ugly, the shading. But can you see what I'm getting at? So it becomes oopsie. Can see? So now I have fifths each. Can see? So I'm actually grouping into fifths. So the common factor that I divide by this by, it was divided by 3, divide by 3, so it's 1 and 1/3. The 1 whole stays the same, and then this one you divide by common factor of 2, you get 2 and 4/5. Is okay? All right, yeah. Okay, moving on. Now, yesterday we went on to talk about improper fraction. The past few days from last Friday onwards till yesterday, we were talking about improper fractions. So the key about improper fractions is that the idea of every fraction is made up of what you call unit fractions. And my tip to you is always ask yourself, if I have one whole, what is the denominator? The denominator will tell us the unit fraction. Can you understand what I'm talking about? So if I were to look at, say, my workbook, okay, if I look at my workbook here, my question will be, every time I see a word like this, at the top part for this question, this tells me the unit fraction. This tells me the unit fraction that I'm looking at. So what does 1 unit look like? Okay. Now, so in other words, say for example, I'm looking at halves. So I ask myself, oh, I'm looking for halves. So I should be looking for the half that looks like this. If I'm looking at B, C, I'm looking at halves. This is what I'm talking about, I have halves. Okay? And C, I have 3 of these halves. 1 unit will be a half. I have 3 of it. So 1, 2, and 3. So I will mean 3 of the halves. Okay? So the numerator here is 3. It tells me there are 3 pieces of the halves. Can you understand that? I have 3 pieces of the halves. 3 halves. Okay? Like the next one, like A, if I'm talking about 8 sevenths, I'm looking at sevenths. So 7 say the unit fraction is 1/7. I have 8 of these 1/7. So I'll be looking for this dark colored one. I have 8 of these 7, meaning I have 1 piece of 7, 2 pieces of 7, 3 pieces of 7, 4 pieces of 7, 5 pieces of 7, 6 pieces of 7, 7 pieces of 7, and there's 8 of them. So I pick another one. Another 7 here. Okay? So I count 1, 2, 3, 4, 5, 6, 7, 8. I have 8 of these 7s. This is how I spell it, 8 sevens. How I write this fraction is actually 8 as a numerator and the denominator 7. What does this mean? It means that, hey, previously, when we were in primary 2, when we first learned fractions, it was impossible that the numerator is bigger than the denominator. When we were in primary 2 and primary 3, we always only knew that the biggest numerator, if I'm looking at 7, it will be 7. Why? Because we are looking at this one whole. Do you understand what I'm talking about? But now at primary 4, I already know that sometimes I won't have just one pizza. I can have more than one. Clear? Like this, more than one. You know what I'm talking about? So if I'm looking at more than one, I have now possibly 2 of the pizzas, 2 of the wholes. If I were to focus on, say, the denominator as 7, how many slices of 7s do I have altogether? Here. If I'm looking at 2 wholes. What are you looking at? Can we focus here? Don't be distracted with people who walk past us. Okay? Now, I say it again. When we were primary 2, we understand that, hey, there's 4. I can cut a 4 pizza to cut into slices to share out. Sometimes I cut into halves. Sometimes I cut into thirds. Sometimes I cut into quarters. Sometimes I cut into fifths. Agree? At primary 2, we learn fractions as always just part of one whole. You will never have slices more than one whole. Meaning, at primary 2 and 3, I understood that if I'm looking at fifths, the biggest fifth I will go is 5 fifths. Because that's one whole. And then there's 4 quarters, 3 thirds, and so on and so forth. But coming to primary 4, I now realize that I can't have more than one pizza. Right? So if I have more than one pizza, let's say I look at the halves now. If I have one whole, and one whole can give me 2 halves like this, what will happen if I have 2 of the wholes? How many halves do you think I will get? I will get 4 halves. Like this. Can you see? 1 of the half, 2 of the half, 3 of the halves, 4 of the halves. And I will write it as the numerator for denominator 2. And the numerator now can become bigger than the denominator. That's why you call it an improper fraction. Okay? Which simply means I now have it is possible to now have fractions that are bigger than one whole. The truth is, it has always been so. But if you were to introduce this at primary 2, you'll probably be very confused. Do you understand what I'm talking about? Okay, so likewise, if I look at these other things, I'm looking at fifth. So that means Fifths, the unit fraction is a fifth. There's 9 of these fifths. So I will actually have 9 of the fifths. 9 1/5. Do you understand? Now this is very important because primary 5 we are going to learn 4 operations of fractions, which is going to be very challenging. Yeah, but if you get this right now, it will be a breeze later. Okay, it will be easier. Now, so this one unit fraction for 6 is 1/6. I have 6 of this, so it will be 6/6. Can you understand? So all these here are called improper fractions. You will notice that all of their numerators are bigger or equal to its denominator. Can you understand that? Okay, so let's try something different. I have my journal with me now. Click on to the new page here. And we really have to have a better or more confident understanding of the relationship between mixed number and improper fraction. Okay, so previously we've heard, okay, over here that a mixed number is made up of whole, okay, so over here I'm going to write down one more time. A mixed number, the term mixed number means that there's a whole number part. It can be a whole number or numbers, and there's a fraction part. Some examples include 1.5, 3 and 2/8 or 2/7. Okay, let's use the simplest form. Any other examples of whole numbers and fractions that give you mixed numbers? So you can give me any examples. Yeah. 4 wholes and half. So you say 4.5. Okay. Okay. Give me another example, Shamila. Another example of a whole mixed fraction. Mixed number. Sorry, mixed number. So mixed number is like a mixed sum, like a rojak of whole number plus fraction. Okay. So some examples is 1.5, 3 and 2/7, 4.5. Yes. Anyone? 5 and 1/4. All right. So 5 and 1/4 is made out of 5 as a whole number and 1/4 as a fraction part. Okay. 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 So we just look at this 1, 2, 3, 4 example. Any other examples? Kevin, give me one. Any mixed number. Give me a mixed number. Any mixed number. Any example. Any number. Give me any number from 1 to 20. Sorry? 15. Okay. Well, how? Give me a fraction. Any fraction. I have many halves already. Can you give me something other than half? Now, Wen Hao has to learn to speak up. Otherwise, it's not engaged in class. Kellen suggests fifths. How many fifths do you suggest, Hao? 3/5. Okay, thank you. So here are some examples. 1.5, 3 and 2/7, 4.5, 5 and 1/4, 15 and 3/5. These are all examples of mixed numbers. They are made up of a whole number part as well as a fraction part. In this case, all these fractions are proper fractions. None of these fractions have their numerator larger than denominator. Can you understand that? Okay, then look at examples of improper fractions. Now, improper fractions means the numerator is either equal or bigger than the denominator. Denominator, like terminator. Yeah, but really fractions sometimes really become terminator, kill a lot of people. Very difficult. Fraction. I understand that we have covered up to quite a bit of fractions. Later, I have a special task arranged for you. The iPads are here. You will have to catch up on symmetry. I prepared the papers for you to try out. That's just here as well. Okay, so you have to try it later. But still, I'll continue with my fractions first. I need you to be on this task still. Okay, now, improper fractions now mean there is definitely bigger than one whole. You're likely to have more than one whole. Okay. Okay. Okay, let's look at some examples. For example, we had just now we had in our workbook, we had 8/7. Even 6/6 was considered improper because the numerator equals the denominator. We had 3/2. And we also had 9/5. Okay, any other examples? Let's go with 7. An example of the improper fractions. Yes, 15/8. Okay, 15 out of 8. Okay, Trevor, I'm still back to you. Give me a denominator, any number. 1 to 100, any number. 8 as well. Okay, he likes 8 as a denominator. What is a possible numerator? Yes, Helen? Suggest a numerator. Yes, Lisa. 6? Is this 6/8 an improper fraction? No, cannot. Yes, 9/8 possible? Okay, so these are all improper fractions. Can you see the difference? Can you tell them apart? Can you tell them apart? Is this okay for you? Now, if you're okay, we're moving on. Okay, okay. Okay, moving on. Okay, fresh page now. Now I'm going to use these examples that we just created, and we're going to link them together. Okay, so mixed number examples, and then we have improper fractions examples. Now we're dealing with the conversion a lot. Okay, right now that's what we're talking about. So, starting off with, let's talk about converting mixed numbers to improper fractions. So, conversion from mixed numbers to improper fractions. Is that okay? Okay, start with the first example. This was the first example here. 1.5. So I have 1.5. The first one is a mixed number. What does this mean? This means I have a whole and then I have a half. Right? That is what this mixed number represents. A whole and a half. 1.5. So I have 1.5. Okay? Is this okay? Now, I have 1.5. Still okay? Okay, now I'm going to turn this whole to make sense in the house. If this is a whole, will I take the yellow, orange, the red one, put here? Can I take this one as a whole, right? It's equals to the whole. Can I use this one? I replace the whole with thirds and I add them together. Is it easy to add this? No, it's gonna be challenging, even though this is also whole. So I won't choose this. I will go back to the halves. Is that okay? I'll go back to the halves. Right? I'll go back to the halves. So one whole is like this. Agree? And then I got one more. So this one whole will become 2 halves plus another 1 half. I will actually get 3 halves. So 1.5 is equals to the improper fraction. So this is a mixed number. And this is the improper fraction. Is it at the simplest form already? Yes. Can see? Is this okay? Okay, yeah? Okay, then move on to the next example already. Okay, next example that was stated here was 3 2/7. Okay, so next example, 3 2/7. Meaning 1, 2, 3 wholes and 2/7. Okay, mixed number. 3 wholes and 2/7. There's 1, 2, 3. 1, 2, 3, and then 2/7. 1 whole, 2 whole, 3 whole, and 2/7.
I can change each whole become 7 sevens. That's correct. So each one I become 7 sevens plus 7 sevens plus 7 sevens plus, don't forget, 2 sevens. What do I get? 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12, 13, 14, 13, 15, 16, 17, 18, 19, 20, 21. So 21 plus 2, 33 sevens. Can you understand? Can you understand? So here, this one, mixed number. This one, improper fraction. Is this okay? Yes? Okay. Okay, you try the next one. The next example was 4.5. Pigeon, can you close the door, please? So I changed the mixed number to improper fraction now. The whole number is 4. The fraction is half. I can change 4 to 1 plus 1 plus 1 plus 1 plus the half. Is that it? Okay. Rasha, what's 1 whole here? What is 1 whole here? So 1 whole equals to? I'm asking you, what is 1 whole? 4.5 is made of 4 wholes and a half. Agree? 1, 2, 3, 4. 4 wholes and a half. If I change to 1 whole per fraction, what will it be? 4. Sorry? Oh. No, I'm not asking for. If this is 1 whole and I'm looking at halves, if I want to replace this whole with halves, how many halves are there? Just 1? 2. Thank you. Please pay attention as well. You need to be able to explain. So 1 will become 2 halves plus 2 halves plus 2 halves plus 2 halves plus 1 half. Now it's not wrong to say, hey, can I actually change to the thirds instead? Would I want to change the whole into thirds? One whole is also thirds, right? Can I change this into thirds instead? Can I? You won't want to do that. Why do you not want to do that? Yeah, because you can't really add them together. It's so difficult to add. So what I want to do is I want to change them all to halves, where the denominator is the same. Then I just have to add, like how I add like fractions when I learn at primary 2. What will be the answer? What's the answer? 9. 9 halves. If I really need to, I can draw 1, 2, 3, 4, 4.5. Half, 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 half. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 halves. Is this okay? Last one for you to try on your own. Let's go with the 5 1/4. So if really I cannot remember how to do, I cannot remember the steps to do. What can I do? I can really just draw 1, 2, 3, 4, 5, and 1/4. I cut them all to quarters. I won't cut into other sizes, the slices, because it will be confusing. Raksha, where's your journal? I heard that you can write very neatly, and your journal is very amazingly done on Friday. Come, do it. These questions are not in the workbook. These are fresh, new questions, examples from your friends. Take this as practice too. I said you can do other things later. Okay? All right, Joshi, can you tell me what is this one? Also, I have 1 plus 1 plus 1 plus 1 plus 1, and then another quarter. So if I were to change this 1 whole into a fraction, what would this be? Sorry? 4/4. Very good. So I will actually have 4/4 of 4/4 plus another 4/4 plus another 4/4 plus another 4/4 plus another 4/4. 1, 2, 3, 4, 5, and then one more quarter. What will be the answer for this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Mixed number to improper fraction. Can you understand? Can you understand this? Now, there's another example. The last final example given by Kevin just now. He wants to challenge us. His example was 15 and 3/5. We need to change 15 and 3/5 into an improper fraction. Wow. 15 and 3/5. Imagine I'm going to draw 15 and count this. How long do you think I will take? Really quite long, right? And that's why yesterday we discussed, is there a shortcut method to this? Yes, right? So yesterday we started to talk about the shortcuts. Remember? So yesterday during lesson time, actually I was doing conversion review at the same time already. But I understood that some of us got confused. So yesterday, this was what Rakshan explained to us. So yesterday, actually, we started talking about the shortcut. I've got 3 holes times 5 parts for each hole. And then I plus the extra, I got 17. So yes, there's actually a shortcut method. If I were to really draw all of them out, it would take me a long time. So let's figure out the shortcut. Starting with the first example here. And the first example is pretty easy. So there's just 1 hole, that's it. Let's look at the second one. Perhaps there's an easier shortcut for this. Now, you don't tell me the steps for the shortcut for this one. 3 what? 3 holes times 7 times 7 what? 7 parts, because each part is a slice. It will give me 21 pieces, so 21 parts. And then plus the 2 extra will give me 23. And this will form the numerator. Can see? Can see? Now these steps here, without the holes and the parts being written down by this name, they don't make sense. This equation doesn't make any sense. But if you want to explain it correctly, I've got 3 holes times 7 parts for each hole. I got 21 parts. 21 parts plus the 2 extra parts here, I got 33/7. Okay, so 4.5, I can actually just write the shortcut as in 4 times 2, that's 8. 8 plus 1, that's 9. And that gives me the numerator 9. But you can write, if you write this in the exam as workings, that's 0. Because these equations doesn't make sense. If we were to write these in an exam, these can form one method mark. Because each of these fractions is properly written and they make sense. This is shortcut like a mental sum. If you don't explain it with wholes and parts, they don't really make sense. Understand? If you don't understand the shortcut method, don't do it now. Go with the drawings if you feel that they help you. Go with the long-winded steps if you think that you understand better. But in the long run, when you reach primary 5, it will be helpful to know the shortcut method. Because like this one. This one, shortcut method, I have 15 holes. Each hole has 5/5, 5 slices each. So I'll just do my working. 15 times 5, I'll actually get 75. So 75/5, I plus the 3 extra fifths here. I actually get 78. So I just convert it to 78. See how quick this is? So JJ, give me another whole number, mixed number. Any number. 20 and 3/4. I can immediately tell you the improper fraction is 83 and 83/4. Come, test me. Fisher, give me another one. Next number. 30 and 2/3. The improper fraction will be 92/3. Oh, very fast. Someone say that. Who did that? Well done. Yeah, as fast as me, I must compete with you. Let's see who's faster. Come, Charlotte, give me another mixed number. 75. Sorry? 35 and 4/5. Oh, I made a mistake. I was hurrying to compete with Rakshan. Wait, hold on. 179/5. Hey, have you got the answer yet? Rakshan, I'm competing with you, no? 35 and 4/5. Am I correct? I may make a mistake, you know. Am I correct? Yes? Yes, I'm correct. And here comes Afik's tip. Afik told us the tip last Friday. What must you practice? Very good. You must practice your division and times table. So this is how I can do conversions really quickly. And that comes with experience and practice. So this was how it came about. I know how many holes and how many slices I have. I add the extra. There was more than the holes, and then I put them together. Now, so who can understand the shortcut method? Okay, so if you're going to use the shortcut method in your working, in your homework, in your test, do it. Okay, I encourage you to do it. But you must make sure you check. Okay? Because if you don't check, you don't know that you got it wrong. Is there any working that you can see here? Not really. So it's either you got it right or it's a 0. But if I am working here like this or like this, then maybe you get a chance at better marks if you make a mistake. Is that okay? Now, to convert from mixed number to improper fraction, that's what we are just doing. Now we do the opposite. Okay? Fresh page now, the opposite. Still at the term conversion. If you are converting from improper fractions now to mixed number. So from mixed numbers to improper fractions, now we look at improper fractions to mixed numbers. So like how yesterday I was explaining to you, the relationship between, I have a younger brother, my younger brother has an older sister that's me. So it's like a two-way relationship, right? I have a younger sister, so my sister has an older sister that's me. So me and my sister, we are related, right? Right? My father has me as a daughter. I, as a daughter, has a father. So me and my father, we talk about it related, now relationship. Okay? Can you understand it? Okay, so here. Look at the examples given to our friend. Starting with the first example, 8/7. The question may come and in the exam time, the question may come in a way that says, express the, very good, the improper fraction as, very good. In the, very good. So in the test time, a question can ask in this manner. Express the following or the improper fraction as a mixed number in its simplest form. The first example given by our friend just now was 8/7. Here. Again, let's do 8/7. Okay, if I want to use the fraction this, I'm looking at 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 of them, 8 of these 7s. Now the concept is simple. Just now I used the whole and I replace it with the parts. Now I take the parts, I try to put back to the whole. Is it okay? So I've got these number of slices. I take my pizza tray out and I try to put it back onto the tray. So I put it back onto the tray. Put it back onto the tray, and I will discover that, yeah, I actually have some extra 7 left behind, like a remainder, right? So what do I get? I actually get 7 7s. Yeah, and then this is 1 whole. Plus 1/7. And what is the mixed number? 1 and 1/7. Can you see? 1 and 1/7. So 8/7. This is an improper fraction. This is a mixed number. Is it in the simplest form? Yes, already simplest form. 8/7. I took out my tray, try to put it back into holes. As I try to put it back into holes, I realize I have one remaining 7. Is that okay? And that's how I got 1 and 1, 7. All right? Yeah. Okay, move on to the next one. The next one example was given, there was 6/6. Three. Wow, very fast, huh? Wow, very expert already, some of you. Oh, I took the wrong one, wrong color. Missed up. Yeah, so I saw 9. Yes, I made a mistake. Where's my 6? Oh, here. I saw 9. Wrong one. 6. Okay, so I've got 6/6. Take the pizza tray out. Try to put it back. This one's pretty easy, right? Can you see the one hole already? Yeah, so you see that one hole appearing already. Right? Okay, so this is just one hole. This one's simple. Next one. Next one was 3 halves. Is it difficult? Is that difficult? 1, 2, and 3. 1 whole and 1.5. So it's just 2 and 2 halves and a half. It just give me 1.5. Improper fraction to mixed number. Is it difficult? Not really, right? Okay, this one's still quite manageable. Just this half, put it together to give me the whole, and then don't forget the extra. Okay, next one. Very fast now. 9/5. One whole and 4/5. You sure? Are you sure? Are you sure so fast? I better check. Looking at the fifths. Okay, I've got 1, 2, 3, 4, 5. 6, 7, 8, 9. Okay. Okay, 9 of them. Try to put them back. 1, 2, 3, 4, and then 5. 5 is, and then 4 more. So 1 whole and 4/5. Is this correct? Yes. So in other words, this was 5/5 plus 4/5. Right? Then this one gives me the 1 whole. Is it okay? So simply easy. Easier. Okay, next one. The next example was 15/8. Oops. Where did my eraser go? Okay, so it was 15/8. So 8/8 plus 7/8. That's give me 1 and 7/8. Is this okay? So far, so good. How about try an even difficult one? Let's go with 38/5. And so 1 of the whole, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 5, 10, 15, 20, 25, 30, 35. 35 and so 1, 2, 3, 4, 5, 6, 7. 7 and 3/5. Is it okay? Now, is there a shortcut? There's a shortcut. Just now this one, there's a shortcut. From next number to improper, there's a shortcut. So from improper to next number, is there a shortcut? What is the shortcut? Tell me, don't tell me. How? Divide what? 38, 5. Gives me 7 remainder. So I get 7 and 3/5. Why does this work? Yes, Zahir? So, closest possible to the numerator. So what does this tells me? 38. What does 38 represent? Yes, Roshan? Very good. The total number of parts. The total number of parts, the total number of fifths. What does 7 tells me? Yes, Jejit. Very good. How many wholes? What does the remainder mean? The number of parts left, the fraction that is left. Who can understand this? Okay, hands up. So the truth is, giving me any improper fraction, I'll be able to solve really quickly with this shortcut here. But this is only possible if I understand why it works. If you don't understand why it works, very soon you'll get confused between the conversion here and conversion here. Now, before you head off for recess, your homework, please try page number 99 to 102. Is that okay? Your homework, everybody, your homework, page 99 to 102. Is that okay? Is that okay? Now, before you really scoot off for recess, there's one last thing. Okay, before you scoot off for recess, one last thing I want to share with you here is this. Rasha, I wanted to share with you the channel where you can catch up on here, where you can catch up on the symmetry lessons. And you see the color activity here, this one here? Yeah, you can come here and pick up the color paper, okay? Later. And then you can catch up what we did in class and why is that over there and paste it up. Okay? And class, please catch up on this. Okay? And your copies, I put out a new revision for term 1 topics. Okay? As well as those of you who haven't done your symmetry and fractions revision for primary 3. Okay, last thing. I've arranged
two new, so our, here this is the, okay, so if you are staying back for iPad recess, you can check out the Tues /4E2022. There are a few. You can try the factor multiples, or the new one is for fractions, factor multiples, and there's one new one on symmetry as well. Okay? All right, so you can try it out. Okay, most of you are heading out. Bye. Why do you not have it? The 4A is with you, right? This is the 4A book. I didn't collect it back. Inside is 4B left. You go and check. Yes, you can. Oh yeah, I wanted you all to do corrections. Never mind. You go to the cupboard there and check beside Russian.